Hello everyone, I'm Mr. Furlong, and today we're talking the metric system. In science, we use the metric system as a way to measure. All scientists around the world use the same system, and even though in the United States it's not one of the more common ways of measuring things, it's about the only way we will ever measure anything is using the metric system, so get used to it. The actual name is the Le Système International des Unités, or the International System of Units. Sometimes it's referred to as the SI system as well. Before we get started on this, we do need to talk a little bit about precision versus accuracy. You see, I want to make sure that whenever you're making measurements that you're always being precise and that you're being accurate, and they are different from one another. So for instance, accuracy is how close a measurement is to the true value. So here's the thing. Every object that we're going to be measuring, there is an actual measurement to that if we're measuring length or mass or whatever. The question is, what is the actual real measurement? Well, depending on our devices that we're using, we may not really know exactly what that true measurement is, but we want to be as accurate as possible. However, we are limited by the types of equipment that we're using. We also want to be precise. So precise is how closely will repeated measurements be to one another. So if I measured something once and I had 12.3 grams, if I measure it a second time, hopefully I get 12.3 grams again. And if I measure it a fourth time, well, I hope I get 12.3 grams again. That would be precise. Is that object really 12.3 grams? It might be more than that, might be a little bit less, but I can be as precise as I can be and as accurate as I can be with the materials that I have. So just to kind of give you an example of precision versus accuracy. Let's say that here I have a target, and let's say I'm shooting at a target. And it looks like my shots are all over the place. You see, I'm not very accurate here, and I'm also not very precise. So this is something we want to avoid when we are taking measurements. However, now when I'm shooting, I'm getting everything in the same ring, so I'm pretty accurate with my shooting, but I'm not precise. It's still all over the board. Well, what if I start doing this and wow, all of my shots are real close together? You know, I'm not very accurate because I'm missing the target, but I am precise. I'm hitting the same spot each time. All of these examples are not meeting the requirement of being both accurate and precise. But now I'm right on the target. I am accurate and I'm precise. And so I want to make sure that we are being both accurate and precise in all of our measurements that we take this year. It's very easy to just kind of round numbers and not be very diligent at trying to get good measurements. But good measurements can make or break a lab. So let's fill out this table real quick. When we are measuring mass, the standard unit for length is a meter. And we simply abbreviate that with the letter M. And the device that we use is called a meter stick, which some people sometimes call a yardstick. It's not the same thing. Or we might use a metric ruler. So a metric ruler, although it is 12 inches in length, it is actually just slightly over 30 centimeters. When we measure mass, the standard unit is the gram, and we abbreviate that with the letter G. The device that we use for this is called a balance. Some people want to refer to it as a scale, but it is not a scale. When we measure volume, the standard unit is the liter. A capital L is the abbreviation. And for this, we will be using a graduated cylinder. And finally, for temperature, we will be using degrees Celsius. The abbreviation is degrees C, and the device that we use is a thermometer. So let's start with length. When we are measuring length, we typically will be measuring things in either meters, centimeters, or millimeters, and we'll talk in another video how we convert from one to another. Whenever we're measuring in centimeters, we will always have one number past the decimal. So if you look closely here, this this black rectangle, if I were to read what this length is, that is going to be 4.7 centimeters. So we can see that there's 4, 1, 2, 3, 4, that's 0.5, 0.6, 0.7 centimeters. When we measure mass, of course, we use a balance, and we will be using electronic balances this year, so we'll talk a little bit about how to properly use electronic balances. But mass tells us the amount of matter in an object. This is where it's different from a scale. A scale tells us weight. Weight is how much the gravitational pull is on an object, which is different than mass. Typically, we will be measuring this in grams. Sometimes you might see things measured in milligrams, like medicine and stuff. What's nice about finding mass is all we have to do is read the display on the balance. So all I have to do is look at this and say, oh, it's 5.02 grams. When we measure volume, this is simply the amount of space that an object takes up. All of our graduated cylinders use milliliters for the measurement of volume. We have different types of graduated cylinders. Of course, here we have 4 examples of a graduated cylinder. Of course, you know what is the difference between a graduated cylinder and a cylinder? A graduated cylinder has a diploma, of course. Anyways, we have different sizes of graduated cylinders, and every graduated cylinder has their own unique graduation to it. And so you'll have to take a look at it and be able to identify, well, what is these going up by? So first, in this first example, here we see 10, and there's only 1, 2, 3, 4, 5 lines between 10 and 20, which means that it's going up by 2 milliliters each time. We always read the bottom of that curvature. That is called the meniscus. Because if we look at the sides, it looks like it's reading at 10.4 milliliters. So we have to read the bottom of the meniscus, which is saying, oh, that's only 10.2 milliliters. In number 2, if I look at this, there's 10, there's 15, and I got 1, 2, 3, 4, 5 there, which means this one's only going up by 1s. If I look at the meniscus, that is at 16 milliliters. Now let's take a look at this next one. Again, it looks like it's going up by 2 milliliters, and so there's my 10, 12, 14 milliliters. So check out this last one. What do you think the volume is? If you said 14 milliliters, you'd be right. Lastly, we're going to be measuring temperature quite a bit this year. Temperature is the average amount of kinetic energy in an object. And don't worry, we'll talk more about this in a later unit. But we measure temperature in degrees Celsius. So although we're not very familiar with degrees Celsius, we like to use degrees Fahrenheit. We're going to be measuring in degrees Celsius. How do we measure these? Again, we have different types of thermometers that we'll be using this year. And if I look at this first one here, the alcohol is right at the 20, so that would be 20 degrees Celsius. Let's take a look at thermometer B. It also is at 20 degrees Celsius. Note the scale. So we have 15 here, we have 20, and so that'd be 16, 17, 18, 19, 20. What about C? What is the temperature of thermometer C? If you said 19 degrees Celsius, you'd be correct. So this year we want to make sure that we're very good at taking measurements. We're going to do some practicing taking some measurements in our very next activity.